Hello, honored algebra students. Mr. Lawrence here, and we're going to continue a little exploration. Some of you did Friday at the end of first period. Some of you didn't quite get there. That's okay. This will be new to you. So if you're like wondering why I'm starting at the beginning, it's because not everybody is in the same place. Excuse me, but we should get them caught up over the weekend here. Now, do remember that on problem number 5 of the homework, I ask for f of 10, but the answer key gives you f of 40. So go ahead and change that f of 10 on number 5 to f of 40, okay? So everybody heard that, good deal. And if you already did f of 10, that's fine. I'm not telling you to do more work. I'm not going to take off for it, but that's just so we can be on the same page. If you already did f of 10 and you got your answer, that's okay. It just won't match the answer key. But if you're sure it's right or you want to check with me, you go right ahead. All right, so let's go find a function to describe this sequence, or this sequence of numbers. Okay, and so let's see here. Making my little table, right? I wonder if I can get those all clicked together. Hold on one second. That way I won't have to redraw this every time. Maybe I will. I don't know. All right. Okay. And so these are my inputs. My x is my input, right? And f of x is my output. And this is the first term, and the second term, and the third term, and the fourth term, and the fifth term. I'm looking for the nth term and the function, consequently, right? So this is a pretty easy one, because look, it goes plus 3, plus 5, plus 7. Oh, you guys know, hey, it's quadratic. I got this, Mr. Lawrence. Absolutely, it's quadratic. So we think it's something like n squared. And we square 1, 4, 9, 16, 25. And we notice that we're 5 short every time. So the nth term must be n squared plus 5. It's 5 more than the n squared pattern, right? And therefore my function, well, we said it's quadratic. I should write that down. It's a quadratic function. And the function is f of x equals x squared plus 5, right? Okay, now let's take a look at this one. It'll be a little bit different. It is going to be a quadratic. All right, so let's call this one, I don't know, g of x, okay? So this will be x, and this will be g of x. And so then we have 1, 2, 3, 4, and 5, and we're looking for the nth term. Okay. Now I was really impressed with Disha. She saw the one on the board real simply. The only problem is maybe that's my fault. I made it too simple for a beginning problem because she might not know this little observation. I don't want to say trick because Colton will think I'm going to do a magic show. And I can do a few magic tricks, Colton, but not in algebra. Okay. No magic going on. So everything is happening for a reason. So let's go ahead and find our differences. So we got what? Plus 6, plus 10, plus 14, and plus 18. And it looks like my second differences are all plus 4. Plus 4. Plus 4. Okay. So it's going to be some type of n squared, right? Something like n squared. Well, let's put these down, and 1 squared is 1, and 2 squared is 4, and 3 squared is 9, and 4 squared is 16, and then 5 squared is 25. Now, if you're Colton Krebs, you go, hey, Mr. Lawrence, this one, they're all off by n squared, right? That's off by 1, and that's off by 4, and that's off by 9. We're off by n squared. So it would be, you could do n squared plus n squared, or you could do 2n squared. And I'm partial to this. This wouldn't be wrong. This is going to show this pattern really well. Now we're going to come back to this in a minute, okay? All right, let's go down to number 3 here. And we're going to do the same thing. Same thing. Let's see. Let me copy that, drag it on down. All right. Okay, and let's see here. I'll rewrite that 27. And we'll call this one h of x. All right, so this will be h of x, and that'll be x. And of course, we have 1, 2, 3, 4, 5, and n. Excuse me. All right, so let's go find our differences here. So it looks like we got what? Plus 9, plus 15, right? Plus 21, and plus 20. No, blank. Wow. 26, right? No. That can't be a 27. What did I do? All right, hold on one second, ladies and gentlemen. Yeah, I have a mistake there. That's not supposed to be a 27. Tell you what, let's see if I can find the pattern without the 27. Let me just take that out. Pretty we only have 4 pieces of data. Oh, it's a 76. There we go. Sorry about that. Sorry about that. 76. Okay, so we'll go back and put that all in. And let me see here. I have x, and I have h of x, and then 1, 2, 3, 4, 5, and n, and n, and n. Okay, and so my differences end up being, what do we say, 9, right? 15. Oh dear. The gremlins are taking over. 15 plus 21, and that'll be 27. Yeah, there we go. Right? Yeah, it's 27. Okay, so the second differences are all plus 6. And so the second differences are all the same. It's going to be an n squared. And so I go boom, 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 boom. And then I put a 1, a 4, a 9, a 16, and a 25. Now these differences are kind of strange. This one's 3 plus 3. I'm going to go ahead and get rid of these first differences here. I'm doing my comparison line. They're just in the way. Okay, this one's 9. This one's, yeah, 9 difference. Wow, my mind is slow today. 19. So I'm not really seeing anything here, right? This one's going to be, what, 33? That 19's bothering me, but that's right. Okay. Huh. Don't know what to do. Let's see, my differences were all what, plus 6? My second differences was what, plus 6, and plus 6, and plus 6. You know, here's an observation. Let's go up here, this first one. Sorry, my table moved on me. Or I moved my table, I should say. On this one, the second differences end up all being plus 2, don't they? Plus 2, plus 2, and plus 2. What's the coefficient on n? Well, it's 1. 1n squared, isn't it? So the second difference is all plus 2, and the coefficient was 1. Huh. On the second one, the coefficient, or the second differences are all plus 4. And look at the coefficient on n squared. It's 2. I wonder if the coefficient on n squared is half of the second difference. I'll say that again. I wonder if the coefficient on n squared should be half of the second difference. So remember, my first difference was what? Plus 9, plus 15. That makes the second difference plus 6, right? This would be plus 21. Look at that. Second difference is plus 6 every time. So maybe I should try a 3n squared. 1, 2, 3, 4, 5. So I'm going to put 1 in here. I'm going to square 1. 1 times 1 is 1. Times 3 is 3. I'm going to get 3. All right, 2 squared is 4. Times 3 is 12. Hey, I'm liking how this is looking. 3 squared is 9. Times 3 is 27. 4 squared is 16 times 3. 48. 5 squared, 25 times 3 is 75. Look at that. They're all 1 short of the number. So n squared is 3n squared plus 1. And therefore, h of x would be 3x squared plus 1. That's a pretty cool trick. That's what Mrs. Clark showed me the other day when I mentioned in the video about how she didn't really get what I did. She went and did her own research, looked something up. She came back with this, and I wasn't sure we were going to be able to get to it, but I thought, oh, it's just too cool a trick to not do it. Let's try one more like that. Excuse me. Let's do. Let's see. Let's do 5 and 20 and 45 and 80, and then let's do 125. I think this is going to do what I want it to do. So let's go looking for the function. Let's see if we can apply this. If I have a mistake, I apologize. So f of x, this will be x, and there's the first, the second, the third, the fourth, the fifth, and we need to find the nth term, right? So find our first difference. We got 15, we got 25, here we have 35, right? And here we have 45. And so these are all plus 10. If my observation is correct, I need an n squared. I need an n squared, I sure do. But I need the coefficient to be half of the difference. So I need 5n squared. So let's try it. Let's try 5n squared and see where it takes us. So 1 squared is 1 times 5. Ooh, it matches. 2 squared is 4 times 5 is 20. Well, let's check one more time. 3 squared, 9 times 5, 45. It works. It's 5n squared. Okay, f of x will equal 5x squared. So to get the coefficient, we need half of the difference. All right? Now, this one here, number 4, is kind of tricky. Let's see what happens here. This is kind of a tricky one. I really like it. I love learning new things. Okay, and this is something new to me. All right, so there's x, and let's call this g of x. So there's 1, 2, 3, 4, and 5. And let's go looking for our differences. So I got, what, 17, and there is 27, and there's 37, and is that 47? Yeah, I think it is. So my second differences are plus 10, plus 10, plus 10. So that means that this is going to be a 5n squared, right? It's n squared because the second difference is the same, but it's going to be a 5n squared. Now, let's put my comparison line here. Okay, and so 1 squared is 5. That's a difference of 1. And 2 squared 4 is 20. That's a difference of 3. Okay, 9, that's 45. That's a difference of 5. Okay. Where am I at? 4, 16, 80. That's a difference of 7. Okay. I'll bet this one's going to be a difference of 9. 125. Yep, sure enough, 9. But I don't know what to write here. I see this number 13579. I see that series. Maybe I can do another table. Maybe I can take 1, 3, 5, 7, 9, put it in a table, get its function, and then combine the two. So let's see here. We'll call this x, and we'll call this h of x. And there's 1, 2, 3, 4, 5. And it looks like right off the bat it's plus 2, right? So that means this part of it is linear. This part is linear, so I'm going to do, for the nth one, I'm going to do 2n. do my comparison on it. We get 2, 4, 6, 8, 10, but then I have to subtract 1. Don't I? Subtract 1, 6 to 5. 2 into 1, I have to subtract 1. So it'll be 2n minus 1. I wonder if the nth term of the original will be the 5n squared plus that. So in other words, I think it's going to be 5n squared plus 2n minus 1. This came from this linear table, this linear function, and this came from the quadratic part. Okay? If that's the case, that means that the excuse me, the function, if I'm right, the function should be, let me make myself some room here to write this down. Okay, the function should be 5x squared plus 2x minus 1. Well, let's see if we can do it. Let's try it with 5. All right, so I'm going to do 5 times 5 squared plus 2 times 5 minus 1. Well, that's 125, right? That's 10. That's minus 1. 135 minus 1, 134. Look at that. It matches perfectly. All right, let's try it with 2. All right, so I'm going to go 5 times 2 squared plus 2 times 2 minus 1. So that'll be 4 times 5 is 20 plus 4 minus 1. That'll be 23. Oh, look at that. It matches. All right, I'll use 1. 1 should be easy. 5 times 1 squared plus 2 times 1 minus 1. 1, 5, 2 minus 1 should be 6. And there it is. That's a pretty cool trick. So when I got some differences that I didn't know what to do with, I went ahead and made another table. Turned out it to be a linear pattern. Then I combined the quadratic with the linear. All right, that's it for the video. Mr. Laurence signing off. Have a good night, everybody.